Now we have a parabola. They want us to give the vertex the axis, and when they say the axis, of course, that's the axis of symmetry, which is that line in which it will spin. We're going to talk about the domain, the range, but I'm going to add to that intercepts. So, oh, maybe I can recognize. Yay, intercepts. So we're going to add to that intercepts. And when I say intercepts, there's two types of intercepts. One, because there are two axes, which is the x and the y axis, then that means that this parabola could probably intercept the y-axis as well as the x-axis. Okay? So we're going to look for all those axes as well. So, if this is a parabola, okay, obviously it's not on the side because it's not a square root, but it is a parabola facing either up or down. Think about what the domain of this function is. Okay? If it's positive or if it's negative, doesn't matter. It's a parabola, right? Think about what the domain is in this case and what the domain should be. Jay, what do you think? What's the domain look like? Domain, we're talking about the values of x. Okay, when you think domain, what can x be? So, if it's a parabola, okay, if it's a parabola, thank you. I know you got it. What can y be? Sorry, not what can y be. What are the values of x? All right, Jacob, go ahead now, so everybody can hear you. Yeah, it's going to go from negative infinity all the way to positive infinity. Okay, it's just going to grow in both directions. So it's going forever negative infinity, going forever positive infinity. Okay, so domain should always be from negative infinita, positive infinita. Boom. The only one that's going to change is going to be the range, because it depends on whether there's a vertical shift or not, right? Because if that parabola is centered at the origin, sorry, I missed it, but make a point, then that means that the range would just be 0 to infinity or all positive if you want. Okay? But if that parabola gets shifted up, then the range would be from that point up. So we need to figure out what that point is, right? Or if it got shifted down, we still need to know what that point is, because then it's from that point up. Unless it's inverted, then it would be from that point down, right? So it's very important for us to know where that point is. And what is the name of that point that we're looking for? The vertex. Okay? So, let's get rid of this. That's made it worse. Delete. Oh, I hit paste. Oh, you know what? Wow. Okay, so we've got domain. We need vertex, axis of symmetry, domain, range, intercept. So let's talk about some of these. Right now, just by looking at this, there's a couple things I can tell you. I can tell you the domain. Domain's positive infinity to negative infinity, always. Sorry, negative infinity to positive infinity. Second thing I can tell you right away is one of the intercepts. One of the intercepts. Okay? Examine the way it looks right now. Can someone tell me what one of the intercepts is? 5. Negative 8. 6. 14. 25.
207.
Okay, let's use that vocabulary. Let's use complete sentences. We are in school. Can I try that again? Let me think about my sentence here.
The y-intercept.
Beautiful.
Is
5. 6. No, the y-intercept is something to do with 5. I know that we've done that for a long time, but now we have to be careful because there are also x-intercepts, which we don't want to confuse with, right? So please understand that a intercept is simply some specific position in the xy chart, right? In the xy chart. So if we're going to talk about the y-intercept, then it would be
0, 5.
Beautiful. You're amazing. 0, 5. Questions on why that is 0, 5? Because he's ready to answer them. It simply is this. If you stop and think about this, here's my axis, right? Everyone know XY? Coordinate grid, graphing, whatever you want to call it. And I put a graph on it. This is the point where the graph intercepts the y. Correct? So, give me a coordinate for that. Make it up. It's not this one, because it's different. But if you make this up, what's the value of x going to be here? 0. Used to be 22. Changed it. Okay? But what if I move that down? What would the value of x be here? It will still be 0, right? So we get the y value when we make x 0. And that's where the number came from. We make this 0, we make this 0. We're going to find out what aka y truly is. So when x is 0, y has a value of 5. And that's how we got it. Nice job. Ooh.
Ew.
No, I didn't say ew, I said ooh.
Yeah, I said ew.
Oh, you said it. My bad. Questions on how to get your y-intercept here? Make x
My hair's like
0. Fantastic. Let's see here. Let's go for the next one. So we have, do we have a vertex? We don't have a vertex yet, but I know that in order to get a vertex, I need an axis of symmetry. So I'm going to do that next. Let me use the red color here. I know that the axis of symmetry is at negative b divided by 2 times a, which is negative 6 divided by 2 times 1. Therefore, my axis of symmetry is at x equals 3. So let me get rid of this here, because that's obviously not it. Okay? So here's my axis of symmetry. I've got u down, because there's only one axis of symmetry. Now that I have an axis of symmetry, I can go for my vertex. How? Raina, did you catch that? He said it kind of fast. What did they say? Plug in the 3, because this generates y's, doesn't it? That is a y generator. So if I plug in the 3 in there, it's going to tell me what the value of y is when x is 3. And it has to be 3 because the vertex is on the axis of symmetry. Therefore, I've got 9 minus 18 plus 5. So y is 13 minus 18. Therefore, y is negative 5? No? What did I mess up?
It's negative 4. Because 9 minus 18 is negative 9 plus 5.
Ah! This should be 14.
Yeah.
That should be negative 4. Good looking out. Okay? Yes?
You can't just do it so that you like when you put the parentheses around it and it's like squared or whatever. X minus 3.
Mm-hmm. That's a different method. Which is the complete the square one, what you're doing?
Yeah.
Yeah, beautiful. If you want to do it that way. Yeah, I can do it that way too if you want. But it's gonna give me the information very differently. Okay? It's gonna be how I look at that. But right now I'm showing you one way that I can go through that process. Okay? So this helped me produce, let me change this color. Oh, you stay there. This purple, yay. That helped me find, no, you don't want purple. That my vertex is at 3, comma, negative 4. I'll just put a little v right here. What?
You said negative 4, but you didn't.
I wrote it there. My bad, my bad, my bad.
So dedicated.
Okay, so I've got domain. I've got domain. I don't have range. I do have a vertex. I have an axis of symmetry. I need range. But now that I have the vertex, I should be able to find my range, right? For starters, I know that this parabola is facing up. How do I know? Because the leading A is positive, so it's facing up. That means that my range, what color do you guys want?
Green.
Green. That one?
Yeah, that looks cool.
Or like the bright green? Okay, so my range, because it is doing something like this. What is it? 1, 2, 3, 4. That's a lot of bright. But anyways, I just know that the lowest point is at -4. Therefore, my range, woo, it's hurting my eyes a little bit. What's my range going to be? It's going to be a bracket, -4, comma, positive infinity, parenthesis. Think about why that is for a second, because I'm going to call on you. Well, actually, I'm going to call on somebody, and then RG's going to answer. That was your answer.
No, it wasn't.
Don't throw me under the bus.
I'm gonna take off.
Can you guys see that green okay?
No.
The closer I get to it, the less I see it.
I can't see that at all.
Are you colorblind?
Yeah.
Might be.
Just make it like teal. Teal.
Ew. It's worse.
Is that like a pretty now?
No, that's brown. It's pastel.
Ew.
I love pastels. How about
These are like dark blue. Got the.
that will work, right?
That would be incredible.
Wait, what's the accent? How was your Saturday shoot? Good. You survived. I did. I was in the stage.
Class Dojo, come to me.
What's a good AC? What's like a good ACT?
Take some water. I'll jump back.
What's an ACT?
I don't know. That's why I'm confused.
I don't know.
Most universities accept 19 overall, but a 20 to 30.
Oh, okay. What's it out of? Okay. That's more.
I know I took one of them.
I was like at a.
I don't remember why.
I'm like.
Okay, here we go. And the question goes to Ruben Altabarino.
Is the parabolas on the bottom?
Thank you. Go.
Parabolas on the bottom?
What do you mean by the parabolas on the bottom?
Like, since you got -4, positive infinity, if it was on top, it would be negative infinity to whatever. I don't know.
I like what you're doing there, but let's stop and think about this. Here is my parabola, and it did go. What was the vertex at? -3, -4. 1, 2, 3. 1, 2, 3, 4. Right. That is the lowest point. That is the lowest point of the parabola, and I say lowest point because the parabola faces up. It's smiling. Okay, that means it goes up, and I don't remember where my y-intercept was to put it on there, but it kind of looks like that. Okay, what I care about, what I'm telling the reader here is, where's the red of this? Where is the parabola? Well, is the parabola anywhere down here at -5? No. It isn't, is it? Okay, so what I want you, here's the best way to think about it is, do this, is put a line there, and then it goes that way, doesn't it? If I'm thinking about y, which is this one, it starts here at the lowest point and it moves up, doesn't it? So I'm talking about that line. So that line goes from -4 and it goes up to positive infinity. And this should be a bracket, sorry. Does that make sense? Okay. Now, if I'm talking about domain, did you understand what domain was? Why it was negative infinity, positive infinity? You do? Okay. Well, I'm going to say it anyway for everybody else that didn't. Okay. If I'm talking about domain, what am I worried about? What x can be? Well, I could go back to the same point, and I'm going to think about, well, where does this function on the x, where does it go on x? Well, it seems to be going this way. There's always something going this way, right? And it goes on forever that way. Same thing in this direction. If I go this way, it goes on forever that way. So it's the green line I'm describing in the domain. Going from negative infinity to positive infinity. I should stop saying that. I'm going to get used to it. Because it's funny. That's why I say I got to stop saying that. I'm going to get used to it. And I'm going to say it for real. Like yesterday, I was listening to a speaker, and they're talking about, you're trying to say the word infinite, and he was saying infinite. I'm like, it's not infinite. There's no GH in there, bro.
I'm getting the chill.
Questions on this problem? Okay, so. Well, where am I going? I've got all kinds of stuff up here. Did I close my parabola? I did, didn't I?
I don't know what you did.
I closed my presentation. Why did I do that?
Oh,
It's okay, look at that. I got a shortcut.
oh. I could cut all the cuss words in the book right now. I wonder how many cuss words there are.
Okay. Objective 3. Corner away, please. Oh, what's wrong with your fingers? You guys want the hangnails? Just ran it out. You never done that?
Who is he talking to?
What?
So disgusting.
I'm going to get back to the recording here. Objective 3. Use a discriminant to find the number of x-intercepts of a parabola with a vertical axis. Whoa, 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 what? You just told, wait a minute. You said the discriminant told me how many solutions I was going to have. You're also going to tell me how many x-intercepts I'm going to have? Because those are the solutions. Those are the intercepts. Okay? If I have a discriminant, okay, take a look at these two parabolas. Do either one of those two parabolas cross the x-intercept? Sorry, cross the x-axis. The x. Yes.
No.
Do any of those two parabolas cross the x-axis? No. So the discriminant here will produce a negative number. That will produce a negative number. So here you see that the discriminant is less than 0. That's when you get a negative. You get no intercepts. If the discriminant is equal to 0, you get 1 intercept. Okay? And that's because they only touch one time. It touches the x-axis and then it bounces. And then the last scenario is when you have a positive number in that discriminant. It's going to cross twice. Now, they won't always both be positive, or they won't both be negative, sorry, or they won't both be negative. They're just example to tell you, hey, here's what's happening. It's crossing the x-axis twice. So you can get 3 crosses, 2 crosses, 1 cross, or no crosses. Brandon? Morning. What? Greco, you're here.
Yeah. She's been here.
No, not when I took your pen.
No, she was
She was here.
Here.
She was not in her chair. And I didn't have
Wait, Munoz, was I here?
Who was?
I'm pretty sure I was here.
I just felt too wrong.
And Alberto, you got a pass?
No, I don't.
Munoz, what did you say about the first one again? It's gonna be negative?
Yeah, if the discriminant is negative,
Okay.
less than 0. I should clear this thing so you can see that better.
How?
Okay.
Yeah. Okay.
Jared?
Oh, I'm sorry.
All right.
I'm serious, Penny.
Yeah, I'll play this too.
What do you say? I asked him, he was like, you have to breathe? That's what I brought up. I'm about to bring one. I'm so dead. I can't get in my chair.
If I stop breathing, there's an EpiPen in the front pocket here.
Is it really?
Yes. Stop, because I'm allergic to stuff. I don't know what it is.
What perfume?
Oh yeah.
Yeah, there's stuff in there too that.
You don't know what you're allergic to?
Yeah, last time my nose got plugged.
Do you know what you're allergic to?
No,
You should probably go to the doctor.
I have. He can't fix. He doesn't know.
You haven't done the
I did. They did my whole back scratch
where
thing.
they do like the
Yeah.
back thing and Your back turned blue one day. Well, it's kind of cool to watch.
It didn't turn into, it's not fun.
It's cool to watch.
No.
You're allergic to
They had a,
I just say it was fun to experience. I'm allergic to like everything: trees, grass, cats, dogs.
Yeah, like the
Chair
has
just
a
gotta
dog
go.
too.
Can I get a power washer for the chair?
You already told me you did, and I said yes.
Oh my god, I don't want to watch that.
Actually, I'm gonna bring it up closer, just in case. Because my nose is stuffing again.
How much are those?
Too much.
Kelly.
Alright, moving on.
Oh my gosh.
Here is our example. It wants to find the discriminant and determine how many intercepts this is going to have. And tell me where they're at. Oh, that's how we didn't do on the other problem. But anyways, we're doing it now. So go. Find me the discriminant.
Wait, Linus, I know you have Febreze. Could you spray it in for
It's already out.
And you're not allergic to it?
Not the Febreze, but I don't know what's in that perfume, and it closes my nose. So it's
I don't know what's
that's
in it.
reacting with me somehow. I'm reacting to it somehow.
You're discriminating.
Yeah.
Perfume.
That's pretty much it.
He's like, oh well.
It's not me though, it's my body. It's not like I'm saying, it sucks. It's actually,
You're a perfume.
I can still smell a little bit.
I can't smell it. It really does make it smell better. It reeks.
Well, I can't, it's closing. This side's already closed.
Air freshener. Or those little ones that are like this. Yeah.
Go ahead. Just buy us Febreze. Yeah. I'm gonna bring bring that.
He gives it to me.
Not necessarily.
Like I can stop going right now if I want to, but
Like, no, you're gonna fucking still. You're not gonna
that's why I was like,
let me know.
no, I didn't say I was gonna do it. I said I could. I know what you're saying.
I made 10 pounds of chicken and it's all going like my
I'll get things done in time, but like 10 minutes before you leave.
2 points, actually. It might be 2, 1, or none.
No, my grandson.
Just a big square. You have to take a square root. I'll tell you what the square root tells you, but all you need is that number exactly. Just find the square root. Stop and think about it. If you're taking the square root of a positive number, you're going to get 2 numbers, right? If you're taking the square root of 0, what is the square root of 0?
So we have to find everything while we did.
Right, so you get one solution. You take the square root of a negative number, then you go to imaginary. So I really think you should take the square root of it to decide what it is.
I'm so dead.
Remember the quadratic. Remember the quadratic formula? It's inside the number. That's the discriminant. That's good. Tell me solutions.
No, don't do it.
Not necessarily. Yeah, in this case.
Determine our number. My graph.
All you need is a discriminant, right? What's the discriminant? You remember the quadratic equation? You remember what's inside the discriminant? That's the discriminant. Yeah! No, that's baby. Almost positive. I know you're right. B squared minus 4ac all over 2. Eso, mucho bueno.
So you can like match it, or whatever. I didn't say like. Oh, no.
So that will tell you. You have the bowl right there. You're gonna get more super nuts.
That's the one right there. You can't see it.
Today.
No, you're right. That's why I gave you a fist and an exploding rock.
It is negative 3.
That's positive. You don't give me positive reinforcement?
Minus.
You need hugs? Is that what it is?
Negative 2.
The proper workplace is all the
Same thing.
That's looking good. See some beard oils. No, beard oil is cool. Mix it all something. No. Depends which one you get. I know what you're talking about. I got one.
You're telling me
Just give me a week
you
and a
use
half.
it like 10 years.
Didn't it say pelo chino? I have a brother-in-law. He says he has pelo chino. It means aquí chi, aquí no.
Something like that. Like I get a lot on the outside and then on the center.
My brother, when he tries to grow a beard, he just gets like the little soul patch and like little sprinkles everywhere.
That's what my dad is like. I feel like there's a path to like nothing.
Did he used to yank it or something? Because if you do that long enough,
All the same.
Credit?
The sides are it's the same formula.
Oh.
You're gonna get 2. Or no, you're gonna get 1. Same thing. You're just gonna get 1. You're gonna get it.
That's not the big stuff.
Oh, the ones that stand outside? I know, I did distributed before, so I did. Not distributed, but I did before. Why'd you get cut? What is that?
If you want money.
What would you do?
Yeah, don't do that. Yeah, don't do that. Anyway.
I have 2 jobs and I'm thinking about like a job. I don't get a different. Do you know how dark I get? I get dark on the same
Yeah, you're full.
You're right. Mr. Munoz. We get the. Okay, we found a collector donor. I was like, what? We collected and we got 25. One. Just one.
This is your number right here, right? Is that number?
Oh, no. Yeah.
That's all?
So we didn't even need to grab it?
No, not really.
Wow.
Okay.
You made me run it. Oh, no. Okay, okay.
He is not.
All right, welcome back. So, try this again. Welcome back.
Howdy, partner.
Thank you, love. Just for putting your phone back down. Okay. So we have the problem. All we were trying to do is figure out whether it has zero x-intercepts, which is the same thing as a solution.
I'm dead.
One solution, 0 solutions, or 2 solutions. So we know the values are A, B, and C accordingly if it's already put in standard form. Brandon? Good morning, Sunshine. So we're plugging into the discriminant. Oh my goodness. The discriminant. B squared minus 4AC. Plug those values in. All I care about is what that number is. What the sign in front of that is. It's either going to be one of 2 things. It's either going to be a negative number, a positive number, or a 0. And in this case, it turned out to be a positive, which means that I've got 2 solutions. That's it. Okay. Do I know what they are yet? No. Question. Turn to your neighbor. Talk to them about this. How can I get those 2 solutions? And I'm going to call like 3 people. Call like 3 people. How can I get those solutions?
I can do it.
Did you tell your neighbor?
Yeah. Yeah, both can do it. No.
How do you get those solutions? Because 25 is not one of the roots, right? It's not one of the intercepts. The question is, how do you get those intercepts? Yeah, because 25, all that tells me is there's 2. The question is, how do I find those?
Technically, you are. Are you mad? Why are you mad? I heard a screaming.
Well, think about it. Okay, let's say I'm super far on the ice of I got these guys. Where these guys cross, is that super far? You look at it like, oh, just
I don't know what I would Why are you questioning him? He had one like that. I still don't do that. Wait. Yeah. You cannot call us.
Thank you. Thank you. Let's have the dojo call somebody. Oh, this one's for Ruben. Brittany Hernandez, what did you come up with?
0, 2.
Say a little bit more, please.
Oh, the x-intercept is 0, 2. Or the
That's
y-intercept.
that's the y-intercept.
Yeah.
Okay. Well, thank you. But we're looking for not the y-intercept, but we're looking for
Oh, the axis.
x-intercept.
Okay, would it
Okay.
be negative 6?
-6? Why -6? What are you talking about?
I found the axis. Never mind. I found the axis.
Okay, and that's a fantastic point. Somebody else also brought up the axis of symmetry.
Okay.
So here's what I said to them. Imagine my body has the axis of symmetry for a parabola. Okay? And here's my extensions.
Yeah.
Do my arms have to cross the same place my body does? Will they?
Yeah.
Will they?
Well, don't they have to go through you?
So if I have this going on, here's a parabola, right? Here's the axis of symmetry. Does the axis of symmetry always cross where those points are at? Not always. Only if there was one solution, then yes,
Okay.
that would be true. Actually, that's pretty cool. I didn't even think about that. It would be if it is one solution. So if the axis of symmetry only has one point, then yes, those would probably have the same x value. But not if it's a two solution, which in this case it was, right? So the question is, how do I get those? How do I get these two positions?
You find the axis of symmetry, then you plug it back into the problem.
If I plug that back into the problem, all that does is give me the y value for that, which produces a vertex. Thank you.
I thought it gave you the x. That's what it did for the last problem.
It gave me the x value for the vertex, which is the lowest point.
Yeah, never
Right?
mind.
Okay, thank you very much. Let's call somebody else. This one's for you. Josh West, what'd you guys come up with?
For which one?
Same question. Well, the question is, how do we find those x-intercepts?
Just plug it in to the equation, right?
I think that's what Brady just said a minute ago. I need you to be engaged and active in listening, sir. David Carlos. How do I get those two x-intercepts, the two solutions that you just called them? How can I go about that? Absolutely. Using the quadratic formula is one of the ways that I can get those two. I plug all those values in, this gives me two values, and those are the x-intercepts. Fantastic. I said I was going to call 4 people.
Except three.
Okay. Well, here's one more then. Serena Martinez Bernal is not here no more. Did she go?
My heart dropped, I swear.
Steve! The quadratic's already taken. Can you think of another way of finding those solutions?
I did ask.
Was that yours? Yeah. Okay, that was a good save. I like that. Okay. Since that's going to be everybody else's solution, that's what I was going to say. The other way you can do it is to factor it. You guys remember that? When you factored it and then each part you set equal to 0, using the 0 property? Right? So if I did, does that even, yeah, it is factorable because we got a, you guys got 25, right? So if I did this, y equals 3x, let's go negative, negative. Two numbers, what are they? This should be a 2, right? No, because that would, no, that would be good. Yeah. Plus, negative. Does that work?
Yeah, but the 2 and the 3. Because if you multiply negative
6, okay, you're right. So positive 2 minus 1? No. Negative 2, negative 1? That's negative 3. That's positive 3. Minus 2 is a positive 1. So I want this one to be positive. No.
associated with negative, the 3x is positive.
The 3x is positive? Okay. So 3x is positive. So let's see here. And the x is negative? Because one of them has to be negative to get that negative 3x squared. Right? So that's what's negative. Then this would give me 3 plus 2. So this would be x minus 1. And what's the other part? Because that's not producing a negative 3x squared.
What I had was that I had 3x minus 2 in one of them. The other one I had negative x minus 1.
Okay, negative, good. So let's see that real quick. So that is negative 3x squared, which is good. That's negative 3x plus 2x, that's good. And there's positive, yep, there it is. So that means that my solutions are x equals 2/3 and x equals 1. Well, I have to kick the, oh, sure, you're right, negative. So I kick that over and then divide by negative. So x equals negative 1. So there's my two solutions. And you would have got the same ones if you used the quadratic equation. So there's your two methods, okay? Write those down, take a picture. But don't forget those. Because I'm not saying that this is going to be on the test, but it's going to be on the test that...
Wait, so it's gonna be on the test?
But you're not saying.
But I'm not saying it's going to be on the test. That you're going to have to find all those things we just talked about. Domain, range, vertex, axis of symmetry, and all the intercepts, aka y-intercepts and x-intercepts.
Ew.
But I'm not saying that.
What is that off of? Who says that? I feel like it's off of Austin Powers.
From Ferris Bueller? No, that would be even greater. Can you believe I have not seen Ferris Bueller? I've seen like pieces of it because you used to show on TV. And I would watch like a second and then I turn away because I was looking for cartoons.
Tommy.
I was like, is that Corbin dad?
I do that.
Yeah, I like saw a bunch of people that all walk
Okay. Okay. We're back to word problems. I'm sure it is. Yep, I'm sure it is. Use quadratics to solve functions, to solve problems involving maximum and minimum. So, a farmer has 100 feet of fencing. He wants to put a fence around a rectangular field next to a building. Find the maximum area he can enclose and the dimensions of the field when the area is maximized. So, well, let's go through it, see if it happens. I don't think it's going to happen in 10 minutes, though. Huh? That's what I'm thinking exactly right there. And if I don't think it's going to happen in 10 minutes. Here, let's go back to here. Here's what I want you to do before you head out. I want you to do these two problems on a clean sheet of paper, and you're going to turn those in, please. And I want you to find, you know what? Not this one. Not this one. I want you to do this one. I want you to find 1. Is it facing up or down? 2. Vertex. Actually, I should try, let's see here. Axis of symmetry. 3. Vertex. 4. All intercepts. 5. Domain and range. Okay. That's 10 minutes or 7 minutes to do that before you head out. You can do it.